Welcome to the Cycle World Podcast. I'm Mark Hoyer. I'm with Kevin Cameron, our technical editor. Our episode this week is on Triumph motorcycles, the revival of Triumph motorcycles under John Bloor. A veritable, zombie. They were kind of making bikes for a while. There was a fella making, Bonnevilles of some kind and using up old parts and making some new ones. But John Bloor did it from scratch, had a reason, a passion, and a desire. That's usually the only reason you get into the motorcycle business.
He called it good commercial business, though. After he got it going.
Yeah, I got to give him credit for having vision and sticking with it. So we'll get into that. They were some of the first motorcycles I tested when I got into the motorcycle business myself. I was just rattling around on my RD 400 Yamaha Daytona Special, which I totaled, as many kids did. This is why you can't find the nice ones now. Or you can. They're just a lot more money than they used to be. But yeah, Trophy 1200, first test bike I ever crashed. It was a magnificent big green motorcycle, 1200cc inline four, fantastic amount of bottom end torque. I messed up a downshift. I essentially fanned the clutch in second gear. I didn't get the first gear as I was going around a very slow corner. Fanned the clutch and extended the fork. It had a very soft fork and it extended, and I rolled out and it went clank. Off I went. It was magnificently, it was one of three in the country at the time. Oh well. We fixed it. So what do you think, Kevin?
Well, first thing is to understand something about John Bloor, which is one of the things that I've taken away from this study, which is that he started this project in 1983 when he was 40 years old. And he had a house building business, and he'd made a great deal of money, having started as a plasterer's apprentice at age 17, and having an eye for the main chance, built his first house before he was 20. So it would appear that he made a lot of good decisions along the way, because England was not exactly a stable business environment in those days, because so much of the value-added industries, such as aviation and shipbuilding and automobiles and motorcycles, were disappearing. And when you read the stories of their disappearances, there are different reasons in every case. So it gives the impression that there was just widespread bad luck, which we don't believe.
I recall we used to watch football, soccer matches on public television as a family back in the 80s. And there was they say it's commercial free, but it isn't commercial free. They have special commercials. And one of those was like the British Trade Association or something. And it showed all this footage of molten metal being poured into molds and factories running. And it was a commercial for Britain in about 1983, 1984. And it said, Britain is booming. Yeah. And it had all this really exciting stuff. And my dad just started laughing. I'm like, what? And he's like, Britain is not booming.
Yes.
So it was good. So that's the world. Britain is not booming.
Yep. So what happened, of course, is that having all this money, for any of us, if we came into a lot of money, poses a problem. Now what? Well, kick back for the rest of your life, sipping margaritas. Well, that's a bore. So Bloor went to look at the recently closed Triumph factory. He wasn't interested in it. but he was interested in the brand name, and he laid out 200,000 pounds for it. Wonderful. And began planning how he would bring the brand back in a new way. What would that new way be? Well, he decided that he should take a few of his trusted lads with him and travel to Japan, much as Edward Turner had done in 1960, to see what they're up to over there. Why go to Japan? Because he felt that Japan had the best manufacturing base and could produce sophisticated products at low prices because of efficient manufacturing. So he went to Japan to see it, and he took his people. And they came back to the UK, and he began to buy machine tools. Well, this reminds me of another time, 1954, when Mr. Honda went to US and Europe to buy machine tools, because Mr. Honda, like Mr. Bloor, believed that the future belonged to highly automated manufacturing at the lowest possible cost. Because what this does, aside from put traditional workmen out of a job, is it makes the product available to a wider population of potential buyers. Because if you're making a few hand-built models that sell for £1 million, you might sell one or two to the Koenigsegg Bugatti crowd, but it's not a business.
Got to give Henry Ford credit, right?
Yes, sir.
Let's make
Because
that
he
car.
had the same idea.
Let's make that affordable enough for my employees to buy one. What do you know?
Yes. And so it was decided to reject everything from the past. That is, they weren't going to say, well, we'll put a balancer on the twin and we'll restyle the triple, but basically keep those things in production. No. Because the whole thing had to be begun on a fresh and modernized basis, or the selling point prices for the various products would not be met. Now, in the beginning, Britain's Industrial Revolution created a nation of skilled workers because so much of the work was of a manual nature. They began manufacturing all kinds of machines, steam engines, for example, ships. Large numbers of skilled people. In the US, they couldn't do that. So the Industrial Revolution in the US took a different form. Right from the beginning, they said to themselves, these people, we don't have time to train them to become machinists and welders and fabricators. So we're going to build the skills into the production machines, mass production, Henry Ford. And so that was a completely different deal. What had happened in Britain was they hung on to craft production methods, or at least to enough of it to poison the rest of the operation, that their production cost was not declining with improvements in manufacturing technology. BSA, who had been regarded as having done pretty well by its employees, didn't see any alternative to cutting employee pay to meet price point. Triumph and BSA decided to build the Fury/Bandit 350 twin, and they had it tooled, no product testing. And then the accountants knocked on the door. Guys, want to run your eye over this? oh, it's going to cost us twice what Japan sells CB350 for. Oh, well, that's that then. And it wasn't too long before I saw in the back pages of one of the British comics, as they used to call them, the weekly newspaper for the motorcycling industry, prototypes for Fury and Bandit were for sale cheap. Those would be some collector's items. At any rate, the British industry had also spent a lot of money on trying to get on trends like scooters. The Italians made a huge success out of scooters, late 50s, early 60s, sold zillions of them. And British industry tried to make scooters, and they had inadequate product testing. They weren't very well designed. Their drives locked up, their chassis bent. They were terrible. There was a product called the Aerial Pixie, which was a tilting wheel, three-wheeler. And this was supposed to just fit in like a glove with the current trend towards wacky, out there lifestyle. And it went nowhere because it didn't work. So all this time, they're bleeding capital. They're trying to keep their products marketable by making a 500 into a 650, into a 700, into a 750, into an 835. Pistons getting bigger and bigger, vibration amplitudes increasing, parts breaking off, unreliability. And then comes the great showdown. Triumph Trident, Triumph BSA 3-cylinder, which has a lovely sound, versus Honda CB750. CB750 somehow outsold the Triumph Triple 10-1. End of story. It's terribly sad because those of us who lived through that period, I was a partner in a dealership. We had Kawasaki and Triumph, and we saw it happening. We would receive shipments of what were called 250 Triumphs, which were BSA C15s, that had been nailed into their chassis. The only way you could get the engine bolts out in order to perform the warranty service, which was actually a final stage of manufacturing that had been neglected, was by using a drift pin and a large hammer. The engines didn't fit the chassis. Well, this is characteristic of when an industry is going to pieces. And Mr. Bloor was determined to have things that went smoothly, parts that fit, a design that was thoroughly modern that people would want to buy, with no legacy of oil leaks, bent transmission shafts, poor stuff, sad, but true. In 1966, Don Brown told me in 1966, BSA had to send back to Britain 4,000 twins that had been so damaged in manufacturing by outraged employees that they couldn't fix them in the usual way, hiring some high school kids, giving them screwdrivers and having them perform the correctives. They had to
Don
had to be manufactured a second time.
Yeah, Don Brown was Don Brown was responsible at Triumph in America for the Bonneville name. So Don had seen a lot. He was an importer and he'd been a bigwig, and he was active in the industry for a very long time, and used to do a newsletter that had a lot of interesting stuff in it. And coincidentally, I worked with his son, who was a battalion chief in the fire department where I volunteer.
Oh.
So. But yeah, Don was really something. I heard those same stories, and our great editor Paul Dean, who worked for many, many years with us, was a BSA dealer, and he once took his own BSA into the basement and remanufactured it himself so that he could have a near perfect BSA. But yeah, handfuls of screws in the cases, just thrown in. Much lore about how they were wrecking them on the line. But the whole thing, I mean, modern manufacturing, the new Triumph, it was just modern. No hand fitting, no fettling, no filing. Just parts that came in and you bolt them together, and that was it.
Machine-made parts feed the production line. It moves along smoothly. Out the end comes a machine that starts and runs and passes the acceptance test in the little shack where they can control the smoke.
Yeah,
there's a roller dyno in there. Yeah,
it was. Yeah, so it was interesting to see Triumph come back to the U.S. market, and I got to test those early bikes, Speed Triple, and that Trophy 1200 4-cylinder. Big sport tourer with bags, giant fairing, pretty bulky, very soft suspension, but man, beautifully torquey engine. The triples were really fun. They were big, bulky, and on the heavy side, but it was such a relief for them to be normal motorcycles.
Yes,
it really was. Like, they just acted like motorcycles. That was really cool.
One of the examples that was given was Enshu automatic machining centers, which produced the crankcases and cylinder heads. Each line was supervised for each shift by 2 people. They didn't touch the machines. They didn't touch the parts. They were there to make sure that if a tool carousel needed another tool that wasn't there, they could load it. They were there to hit the red button if there were some kind of an emergency. And they produced bearing bores that were correctly dimensioned. Now, we all know the story of the Norton crankcases being bored by a man who used a piece of 2x4 with a shiny place in it from wedging it against the tool spindle.
Where's me stick?
Take the clearance out of the spindle bearing so it didn't shatter, and make a surface finish in the bearing that looked like pavement that's been prepared for the next layer. Just terrible. And of course, these Enshu machines, self-managing, took care of the chips. The chips come out on a little conveyor belt and go into barrels for recycling. There's no man, there's no stick. The dimensions are measured in process. So this is what Mr. Bloor meant by rejecting everything from the past and starting afresh. But there was a thing, an underlying concept, which was not missing, but not emphasized. And this turned out to be the role of a fellow whose name I can't pronounce. Maybe it's Tui Mantoni. It looks like that.
Yeah, Tui Mantoni.
He was working for a consulting firm. He's a Dane, and quite a young man when this analysis began. Quite a young man. So,
oh, yeah.
And what he had was a penetrating analysis of this effort to produce a new Triumph motorcycle. He said, get rid of the big fours.
Well, this is
build twins and triples because they have identity. Now, he knew all about identity marketing. Harley did not know about it until their Minneapolis ad firm sort of pushed their face into it. Look, you have something that is 1,000 times better than the best imaginable Nova project you could conceive of. You have the American nationalist motorcycle. Well, twins and triples. The triples have that unique musical sound. I've never understood why it is so attractive. The twins are attractive because Triumph made so many twins beginning in 1936.
It's really important to wind back to the original bikes of the Rebirth and say, here are these kind of big, chunky, reliable things. They had some character. It was good. They made an impression, and everybody said, well, how come you don't have a Bonneville?
Yeah.
And at the time, all the people I talked to at Triumph, I'm standing in Triumph headquarters. No, the strategy is, no, we're going to compete head to head with the Japanese in every category. Ouch, that costs a lot of money.
Yeah.
So, and the thing is like time after time, TT 600. Okay, yeah, not bad, but like 2 years behind, 8%, 5% behind every time a new one came out. And then they said, well, let's make this Daytona 600. That was an evolution. Also not quite there. Pretty good, but not really like, hey, I want to go win a national championship, which was kind of the point of all the 600s at the time. And whether you were going to go win a national championship or not, you wanted the 600 that can do 172 miles an hour.
Yes.
Is sort of how we were being marketed to, and what the customer was buying. 20,000 Honda CBR 600s, 20,000 G6R 600s a year in the United States.
Guys. Good going.
Crazy money. Yep. Yeah. And phenomenal motorcycles. So, but then they said, well, we'll just make it a 650. So they got a Daytona 650, and it was pretty darn good.
Yeah.
The 955 triple was a big transition.
Big step. Yes.
Huge step, because they modernized the engine. They made it lighter. You pointed out, Cosworth influence. So, but the strategy was, we're going to take on the Japanese in every category. They had a hyper bike. They had like a CBR 1100 Blackbird fighter. They were going to go 100, 200 miles an hour, just like a Hayabusa. They had that bike in process, and they were struggling to make all of this stuff happen. And Tui Mantoni came in and said, you have an identity, twins and triples. Use it. Get off that treadmill. You have a business in a way that is your own. You have Triumph. They came out in 2001 with the Bonneville, and you were never going to make the old guys happy. They were all pissed about the kick in the exhaust pipe instead of it having a straight going into the sausage. They kicked it up so the thing would have cornering clearance. And in fact, the Bonneville, interestingly, was in a lot of ways less Triumph than the Kawasaki W650 of the time. The W650 with the bevel driven overhead cam was so remarkably like a Bonneville. It sounded great. It actually nailed the Bonneville more than the Bonneville did. The Bonneville was a really nice, more modern interpretation of Triumph's own Bonneville. But there it was in 2001, and instant hit, and sold. And on that trip, I went to England to test ride that motorcycle when it debuted. And we stayed in Oxford, and the weather report that night was, I look out the window and it's pouring with rain. I see a pigeon, land, and a gust of wind blows the pigeon off of its perch and into a puddle of water. I'm like, you can't, like, the weather's so bad that the birds are getting their asses kicked. And I watched the news, and this woman came on and said, the railway's closed in the north and flooding in the south. And on she went about, and she finished her weather report with, if at all possible, don't leave your homes. I'm like, great, we're going to go riding. We're going riding tomorrow. So it was perfectly British. It was wonderful. But the bike worked great. And during that factory visit, they were running down the line, and they were laying gear sets into the cases and all that. And then I looked in the corner, and there was this great big machine, great cylinder, had like a little window, and you could see like purple flashing out of the window. And I said, "Hey, what's that?" And the guy's like, "Oh, we plasma nitride every crank, and plasma nitriding is bombarding the surface to harden the surface and make it immaculate and durable for a really long time." It was very heartening to see that. It
Yeah.
was like these are legit. These are real modern. There's no stick, no chatter, none of that. We're plasma nitriding our cranks and then walking them over here and stick them in motorcycles. It was good.
Although in 1962, I had a matchless twin apart, and I measured the crank journals 1.6250, right on the money. And that motorcycle had been around the block.
Used?
So I carried this heavy thing to work the next day, and I went to see the foreman in the that branch of the university's machine shop service. And I said, how can this journal come from a very well used motorcycle and still measure the original dimension? Oh, he said, it's nitrided.
Hey, super.
And
I don't want to discredit. I mean, Britain made some fantastic things, and they did a lot of good work. The Edward Turner of Triumph fame. So Edward Turner did the twins. Edward Turner made Triumph styling irresistible. The bikes were gorgeous. They were pretty darn reliable. They weren't perfect, but darn it, they just ran, and they were pretty easy to start. And even when they were kind of off, they were good. He was hired at Daimler, and he designed a couple of Hemi V8s for Daimler cars. And the Daimler 2.5 V8 was using the Daimler Dart, and it was using some Jaguars that were also called Daimlers, and also the 4.5 V8. And the 4.5 was in like the Princess, I think they call it that was a 3-liter 6. But they used them in these big Daimler Majestic Major. That's what it was. It was the Majestic Major limousine, 4.5 liter, gorgeous engine on the outside, Hemi. So the big valve covers and the ignition wires sticks went into the centrally located spark plug. The internals on those engines were forged. The rods and crank were forged. And the 2.5, there was a famous sprinter, a drag racer, who built a drag car using a Daimler 2.5. He was cranking out 1,000 horsepower from a 2.5 liter on stock crank and rods. So yes, magnificent.
Yeah.
But it was nice to see in 2001 to go to Oxford, to get rained on, to be frozen. I learned a trick. I grew up in Southern California. You wash motorcycles, you just turn the hose on, put it in your bucket, wash your bike. But it was like 39 degrees and raining. And we stopped at the pub for lunch, and everybody went inside to sit next to the fire because everybody was cold. But the sun had come out a little bit. There was a break in the clouds. So I grabbed my photographer, David Goldman of Golden Goose, very dedicated, hardworking guy. I said, David, can we go do photos? And he said, absolutely. This is maybe the only time we get light. And so I skipped my meat pie and all that stuff. David Goldman, being British, took the bucket to the kitchen and said, could you fill this with hot water, please? And we washed it with hot water, and we weren't freezing our knuckles off. It was tribal knowledge from England.
Yes.
Use hot water to wash your motorcycle on a cold day. Anyways. Components we were using, that's I think a big difference there for the modern Triumph was there really weren't any suppliers left for the normal hand controls and brakes and all that. And so what do? You get your Nissans and your Showas, and you take advantage of the fact that stuff comes out pretty darn pristine and ready to fit.
The thing that's tough, though, is that you order those things in quantities that you think you'll need, and they come in dribs and drabs. So what John Bloor did was to create a subsidiary, Triumph Thailand, and started out with a components business. Their job was to get together all of the cables and wheels and brake discs and uh, electronics and what have you, load it all into shipping containers and make sure that it got to Britain as needed. So, because Thailand is a big value added manufacturing nation now, they make hundreds of thousands of cars, and they've been producing motorcycles for the Japanese companies for years. So all of that supply network that used to be available in Britain to back up their motorcycle industry, but which atrophied away, now existed in Thailand. And so Triumph connected with it so that they would have a reliable source of all of the things that they weren't going to manufacture themselves. And that was enlarged from time to time until they were manufacturing some of the components and they were preparing to manufacture motorcycles there. Another thing that you would find in Thailand and might not in the UK is you go to the bank and you say, I'd like you to look at my business plan. And the eyebrows go up and then they come down as they see the word manufacturing. We don't do that sort of thing anymore here. But in Thailand, it was normal. Go to the bank, get the money, get online with your product, and start paying it off. That's how banking works. They make successful loans that pay themselves off. So that was another element in the move to Thailand, which began in this century. But another thing that they did was to keep the product line always fresh, to produce new models at a rate that other manufacturers actually weren't matching. Another thing was, and this used to be a strong point of the Japanese, when the market is down, go for market share. And Bloor, when the market was down, said, let's push on, because when the market comes back, we'll be ready, and they will not. And so it turned out. They compared their buyers with those of Harley Davidson. They said, each year, the age of the Harley Davidson buyer increases by 1 year. Over a 10-year period, our buyer's age has fallen. What that means is our product is attractive to younger people and it's affordable for them, so they're buying it. And of course, all these business stories read like, oh, why didn't I think of that? It's all so obvious. But at the time, it's not obvious, because when there's a down market, as there was in 2008, the last thing people want to do is to lay out money. They don't want to tool a new product. The same thing happened around 2002 when the Japanese manufacturers and the European ones had the same light bulb go on at the same time. We'll give them little electronic gizmos for their bikes rather than giving them new models. So it has turned out that the Bloor operation has made a lot of right decisions, just as Mr. Bloor had done before he was 40, so that when he laid out money for this new product, he had spent 90 million pounds tooling buildings. The first building was 120,000 square feet. That's 346 feet on a side if it were square. That's a big building. That's a big gamble. But he had made many gambles before and evidently had a head for figures. And he was able to get it right so often. Well, of course, his son Nick has taken over now. Mr. Bloor is what, 81 now, I think. So he's deserving of whatever he likes. We don't know.
Yeah, when I saw him, I happened to run into him. He wasn't overly excited about it. He was showing up at the office coincidentally, and I happened to be there. And I don't, my memory says it was a helicopter, but it might have been a Range Rover. But I went bounding up because I'm like, well, I can go say hi to the man, and my handler you could see was like slightly uncomfortable with me bounding across the car park to go just to confront Mr. Bloor and say top of the morning to you. But I did. And he was polite, but you could see he was a private person and he wasn't accustomed to journalists running across the yard to say hi. So, yeah, he deserves to do whatever he wishes to do at this point. So by the mid 90s, it was a really different operation, different company, so they were quite conservative coming out of the gate. The designs were very, people were likening them to mid 80s Kawasaki's.
They were, yes.
And,
black
they just
epoxy
had
finish on engine parts,
big blocky pieces. And, they were good looking, but it wasn't, you didn't have a spiritual connection to the previous stuff with all the contours and all that. They made no effort to say like, oh, this is an extension or a relationship with the triple. That was just the old triple. That was all gone. No sausage mufflers. It was just modern motorcycles, pretty conservative. But by the time we get to mid 90s and then like T595, that was, had the tubular aluminum frame. They had made the engines more compact, more valve area, electronic fuel injection. They were, really going full speed ahead in that regard. And they were good motorcycles. I remember one of the years they were looking to kind of refresh the 955 triple 955i. And one of the designers that they had been using finished it in this really beautiful shade of silver with very, very crisp, subdued graphics, just 955i. And it was very handsome. It made an impression. I still remember it. I could see it parked in the parking lot at our old Newport Beach office. And it was fun to ride. Good bike. It was just cool, man. Single-sided swing arm and, all that. It was, it was not a CBR 900RR 954, none of that. It was its own deal. And we were better for it, I think.
In a way, what Triumph were doing all along is what the industry has now been required to do by Euro 5, which is to run valve timing with very little valve overlap. Normally, the intake valves begin to open slightly before top center, and the exhausts, which are still in the final phases of decelerating to the seat, after top dead center. And in the 1930s, race engines like Velocets and so forth would have 85 or 90 degrees of valve overlap. And of course, what that allows to happen is intake flow comes in the intake valve, sees the open exhaust valve, and heads for the high country. And when the EPA is waiting there, or the European Union, the gray men of Brussels, with their 5 gas analyzers, they say, no, you can't operate that in our purview. Get ye hence. So short valve overlap is a major ingredient in grunty, broad range torque. And Triumph had early experience at that. So now they're looking smart for this reason, as well as the others that we've described. Japan is left with all these sport bikes that aren't wanted. So after much thought and argument, they decided that's not going anywhere. We're going to have to build these, what is it? Twins and triples. So the market seems to be confirming what Triumph has done for other reasons. And that's a very attractive story. I like success. Failure scares me. So I feel that this is a wonderful, positive story that shows motorcycles can be built anywhere that you have a stable society, electric power, and trainable people. Even England, as someone pointed out to me, even England. Because all the errors of the past were the result of being first. When you're first at something, as England was with the construction of metal ships, you develop ways of handling everything. You have procedures. You have working people who expect things to be done a certain way. And along come the upstart Germans and the Italians, and those people up in Scandinavia build ships too. And in Germany, they were trying to do things from first principles. When they tried to do things in England from first principles, they ran into trouble with the labor force. Well, you see, we're a craft union and we do things this way. Well, we're going to retrain you so you can do it our way. No, we like our way. So there was a period in England of intense enmity between labor and management, and both sides agreed on one thing. We'd rather go out of business than give an inch. So that's what they did. The British product was not outcompeted by Japan. There wasn't dumping. What had happened was Japan, whose 66 largest cities were burned out by the B-29 assault in 5 months, Japan had no industry left. So they had to start with everything brand new. But Norton still had that boring machine with the loose spindle, and it needed a stick. And so rather than say, Saturday, get the maintenance guys in here and change that bearing out, well, we can't get that bearing. That machine was made in 1929. Oh, well, get the stick. We'll soldier on. Starting afresh gives an advantage. Being first gives an advantage at first. Britain's Industrial Revolution was a true revolution because it placed steam power at human beck and call. You want to forge huge pieces of metal? You want to saw vast timbers? We've got the power to do it. But there's a legacy that comes with being first, which is hard to root out because it has worked. It's always worked before. And so this gave the advantage to the nations that had to start over, and Japan foremost among them.
I mean, England's got the famous Iron Bridge, and it was kind of the crucible of manufacturing. They had everything. They had coal and they had ore, and it was the first iron bridge that was made, and it led to, everything else being made out of metal at, sort of Iron Bridge. I mean, it's crazy that, but yeah, that's where it all
And it's a
began for them.
curious fact that one of the pioneers of metal ship construction was named Scott Russell.
Oh, good times.
Yeah. This Triumph story, of course, we don't know what the future holds, and neither do they. They've got a better handle on it than I do, because that's their whole job, predicting the future and making it. But they have expanded into off-road. They have one motocross machine and probably a larger displacement one coming.
Oh no, it's they've got a 250 and 450 going. We've had them. Yeah, they're competitive. We've dyno tested them for our dirt publication, Dirt Rider.
And the 250 is a thoroughly modern engine. It's something that takes advantage of all that is best in engine design. But then you say, oh, well, what if electrics make rapid progress? What if there's a big battery breakthrough? We don't expect that, because first of all, people, except for city commuters, are not that attracted to electric motorcycles. It turned out, for example, with Harley-Davidson's live wire, that it was very important to people what kind of power plant was in it. It wasn't going to just be, oh, what's it got for power? Oh, it's got an electric motor now. Oh, that'll be fine. I'll bet it's quiet.
It's a big spiritual trouble for, if you look at Honda, and this is coming from the mouths of people within Honda, and same with Harley-Davidson Motor Company, Honda Motor Company.
Yes.
How do we build, particularly for Harley, how do we build something that says it's a Harley-Davidson and it's electric? How does that work? They designed a heartbeat into the live wire so that when you turned it on and you weren't applying the power, they would twitch the engine.
It would quiver a bit to let you know it was there.
Yeah, you would feel something. So, tip of the hat to Brad Richards there on thinking that one through. But still, a total addressable market for electric motorcycles is virtually nil.
Triumph is developing this thing they call TE1, Triumph Electric #1, because it would be foolish not to have your toe in that water, because we can't know what the future will be. What will the gray men of Brussels decide? But at the same time, some German auto manufacturers are saying, we plan to continue developing the internal combustion engine because we believe that synthesized fuels are a definite possibility. Now, what does that mean? It means that you would combine fuels that we burn now are hydrocarbons. They're compounds of hydrogen and carbon atoms. All right, we start in our factory extracting carbon from carbon dioxide in the atmosphere. This is anti-global warming. If you take carbon away, it's a much better thing than continuing to add it in the view of the climate predictors. So then where do you get the hydrogen? You electrolyze it from water using electric power. Where does the electric power come from? It must come entirely from renewables, because that way you can say this is a synthesized renewable fuel, because we can do this process forever and not add anything in the way of carbon to the atmosphere. But, big but, it calls for a large surplus of renewable power, which does not at present exist. So again, we're poking around in the future and we can't feel anything. What's out there? So what you do is you prepare contingencies. contingency plans, and synthesized hydrocarbon fuels are one of the possibilities.
And I would argue that if you needed to roll an electric motorcycle out forthwith, you have everything else that you need going in your current motorcycle. You're not really presented with a huge packaging problem.
No.
And you just make one, and you call, you may have some advantage in your power management and all that other business, the controller and all that. So you probably could find an advantage if you dedicated a bunch of research to that. But the difference between buying Heller crankshaft machines and tooling up for a new engine versus, hey, we need an electric right now, I think the electric prospect is a far more direct line.
So it's hard to see what can happen. Will people continue to talk about batteries improving by leaps and bounds? When I look at it, I see that lithium ion improved for several years at a rate of about 5% a year in terms of energy storage per pound of battery. Then it dropped to 3%, where it has remained. So that has allowed energy storage to double or a bit more. But there's no prospect for a sudden, no later than Friday, super duper battery that will have the same energy density as gasoline or diesel fuel. There are the lithium air battery, which some have put research into. If it could be made to work, would it be a wonderful improvement. But how do you get oxygen out of the air, which has moisture in it, which loves lithium? You have to carry a chemical synthesis unit with you on your vehicle. We want the oxygen, but not the water vapor. You stay over there. That's a good chap. And this is, IBM put a bunch of money into lithium air for several years and decided, not right now. We can't afford to put this much money into this right now with this prospect of success. So people talk about exciting new developments, but when you look in detail at what they are small changes to existing chemistries. Oh, silicon nanorods make a wonderful electrode because they are filled with empty space that ions can populate. Yes, but the nanorods have to conduct electricity, so we coat them with carbon powder. But how do we make the carbon powder stay on there? How do we make it compatible with the electrolyte? These are problems that can occupy years of research. So huge advances are maybe possible, but they're not likely. So the idea of the Energica motorcycle, electric bike, Energica, I think, no longer manufacture. Dorna had an electric class that employed their motorcycle, which weighed 589 pounds. And Dorna basically said, as long as it'll do 10 laps, that's all we need. And so they have that electric class. It's now a Ducati in place of the Energica. So it's a call for gambles. Who's going to win? Of course, then there are the people who say, oh, well, AI will solve this problem in the twinkling of an eye. Let's welcome that when it happens. What do you think?
Yeah. I'm still a fan of natural intelligence.
Well, it can get you into a lot of trouble in marriage and human relationships generally.
Yeah.
Something about experience?
I think the large language models right now are just a fancy autocomplete. It's it does bum me out because we go to great lengths to do good work and post it on our website, and then someone will go to Google, which uses an AI summary, or there are lots of people who are just jumping into Chat GPT and not using Google at all, and they ask questions, and the large language model goes out and it's already read everything, and it interprets your question and gives you an answer. And so here's the AI summary in Google, and you don't even have to come to my website anymore.
Yeah.
They just hand it to you on a platter. Well, we put a lot of human effort into testing that motorcycle.
Yeah.
So we hope to continue. That's why we make videos too.
Yes, it is why we make videos too. I had a good experience, though, this morning with Google. I read an article about how a set of improved alloys of copper and lithium had been made possible by adding small amounts of tantalum. And in the past, they've made copper lithium alloys, but they deteriorate at temperature. They weren't useful. They want to make highly thermally conductive materials that can operate at high temperature. Well, you put tantalum into it. So I looked up how soluble is tantalum in copper? Negligible. So then I thought, how do they get the tantalum in there? I'll bet they use powder metallurgy. They grind it all up real fine, and then they sinter it together. They hip it, hot isostatic processing, and they give it various heat treatments so that the grain boundaries in the lithium copper alloy are covered with a bifilm of tantalum atoms that solve all these problems. I was so pleased because I thought, must be powder metallurgy. So I asked Google and it said, yes, it is prepared by powder metallurgy. But other times I've used it and it sounds like, well, we averaged the opinions that we could find.
Oh, 100%.
Yeah. In other words, no information.
Well, the internet is interesting in that way because, you have the main challenge is signal to noise ratio, because you can say anything. You could I could write down whatever I want and I could get it out there, and it becomes part of the sample. And if you ask, if you have a flat tappet V8 and you're like, well, I'd like to understand, how much ZDDP I would like, how much zinc I would like, and phosphorus, and will it react with calcium? Should I use a diesel oil because maybe the ash dispersants get in the way of the zinc? But you can actually find any opinion that you want or don't want. The signal to noise ratio is terrible. But as you did, you asked a very specific question and you got an answer. And the more specifically you can ask the question, typically the better of an answer that you're going to get. AI summaries often start not too bad, but they always have the disclaimer.
Yeah.
AI summaries can contain errors, whatever it says.
It's like investment advice. Investment advice always has that.
Yeah, but the deeper you
could
go,
lose money.
Yeah, the deeper you go, the more likely you are to start finding gross errors. I was putting the power steering pump back on my pickup truck, and I was like, I look at the reservoir and I think about the volume of the system, and I'm like, less than 2 quarts. I've got it covered, but I just wanted to be sure that I had enough so that I didn't pour it in and then I can't run the truck because I don't have a half a quart of power steering fluid. So I said, hey, dear internet, what's the power steering fluid capacity of a 1989 Ford F-250? 6 liters. Nope. I mean, just right there, it's 6 liters. It's not at all. So
that's the engine. The engine is 6 liters.
It is indeed. It is. And it has flat tappets. Well, I want to say, as much as we liked the traditional Bonneville, the speed twins, the speed twin, they're doing the speed twin 900. They were calling it street twin before, but they've just gone with speed. So they have the speed twin 1200 and the speed twin 900. The 900 is very much spiritually aligned with old Bonneville. It's really wonderful. It's kind of the right size. It's compact. In a lot of ways, I prefer that over the 1200, but you can't beat the 1200 for total satisfaction. They build a beautiful torque curve. It's just wallops right off the bottom, and it slowly tapers down. But it's 4 valves, a little overlap, big plateau torque curve, very satisfying, and a great chassis. I mean, dang, and just you can see through the motorcycle. They've made a point of
that's an important point right there.
Giving you holes to get light through the motorcycle. You look at new Harley touring bikes, and it's like, here's the V, and you can see air, light can come through and highlight the engine. There's space between the rear cylinder and the under seat business.
Yep. Not packed solid.
Yeah, we're pretty dumb, huh?
Not and then, dumb, of course, for those traditionalists who want air cooling, I can only say, if you want it air cooled, you're not going to be able to have 4 valves unless you liquid cool the exhaust valve area, as other manufacturers have done. You're not going to be able to have the 12 or 13 to 1 compression that gives you that right now torque. You're going to be stuck at 9 or 10. So the liquid cooling is there for good reasons. It makes 4 valves last forever.
Yeah. Well, I was real surprised recently. I just finished riding the R12G/S, as they're calling it. It's BMW's new adventure kind of, it's inspired by the R80GS. It's got the orange seat. They made a real strong point of drawing, these lines. They wanted to get, because you have over here, you've got the R1300GS, and the beauty of being BMW is technology on my sleeve. That's what we're here for. That's what that customer wants. Is that motorcycle has electronic ride control, and so when you slow down, it lowers front and rear, and then you take off, it lifts up. Yeah. When you go to put that motorcycle on the center stand, you have the power on. You stand next to it, power's on, engine's off. You push down on the center stand, and as soon as you do that, the pumps start whirring. It raises the suspension, and you just go click right on the center stand, and then it pulls the wheels.
Yeah.
Wonderful. That's what that motorcycle is about. G/S, not about that. G/S it has electronics. It's got Enduro Pro mode, and you can turn off traction control, turn it on. You've got ABS, lean sensitive ABS. You have it, but it's packaged in a nostalgic wrapper. Anyway, the whole point of all of this is that bike has the 1170 flat twin that we've seen for a long time, radial valves and all that business, air oil cooled. The new engine in 2005, the HP2 Enduro had 11 to 1 compression, which I thought was impressive. The new bike is 12 to 1.
Yeah.
On an air oil cooled 4 valve. I'm like, dang, you guys are like 12 to 1, man. That's I mean, that 1300, I believe, is 13 to 1. And it's a fully liquid cooled, and it's remarkable. And we just go look at last week's show. We just did the whole BMW flat twin evolution, and it was inspired by riding that GS and experience of that engine with 130 horse. Really something. But back on Triumph, I want to talk about the cruisers, because everybody has to make a cruiser. BMW's making the R18. They're doing everything they can to sell that bike, and they have a limited market because I believe it's outside the brand identity. It's beautifully done. They took an R32 and they stretched it and made it big, and it's 800 pounds, and it's very evocative of the R32, but it's sort of mixed up with the American long and low thing.
Yeah.
And I think the retro BMW, maybe it would have been more successful to make it more like a BMW and to tap into that ready-made market, because jamming your R32 into Harley space doesn't necessarily give you Harley volume.
Identity.
Yep. And so that's the thing, you know, I went to ride a prototype of the Thunderbird, which was the giant parallel twin that Triumph was making. And I was very surprised to initially ride that and discover that it was a great sport standard engine. It was not a cruiser engine. They did not have the crank mass to make that thing run the way that an American cruiser rider would run. And they asked me, and I told them, I was like, this is a really great sports standard. If you put this in like a real muscle naked, you'd really have something. It's a great power plant, but you couldn't roll the RPM down to like 1,400 and just kind of squeeze into it. It didn't have the mass to keep that smooth, and it would start to buck. And so they went back and
tungsten slugs into the crank.
They went back and did a whole bunch of extra work to mass it up, you know, to get that, whatever it was. I don't know what they ended up with, but a lot of times the cruisers are running 40-pound cranks.
Yes.
To smooth that out and to keep that inertia going when you don't have a power pulse to, you know, accelerate the crank. They just
keep it going. Yeah.
Keep it going. So that was not a resounding success. Again, a really well done motorcycle and really well designed, but not, you know, just wasn't resonating with the market. And everybody always says, like, whatever Harley's volume is, just give me 10%. And they don't even get close.
No.
To 10%. 1, maybe 2%, sure. But that's the 1600 was pretty neat. And then the Rocket 3 was mental. And it still is mental. I'm surprised that they've kept with it as long as they have, but it is a truly unique experience, that inline 3. 3 giant pistons, really just crazy. I threw the clutch on the press launch for one of those, thinking I was going to do a big smoky burnout. And the tire was warm enough and the traction was there, and that thing reared up like a rhinoceros. I mean, it just did a wheelie. I was like, I never would have thought that could happen.
Yeah.
But here we are. It was good. And they've really cemented that bike's identity. I think they did a good job. A lot of their cruisers have been really cool too. The Bobber. Again, lovely bike. I don't think it's sold in mass quantities, but very, very well designed. And of course, they were so successful, and they really built motorcycling expertise right there in the middle of England in Hinckley.
Yep.
And then what does Royal Enfield do? Opens up their technology center down the block, and look at all these motorcycle experts that know how to make twins and air cooling and all that. And they've made some very choice recruitments.
Yes. What'll it take to get you to walk down the street?
Yep. Simon Warburton, man, he was part of the team that did the triple, the 765 triple, and Daytona, and then he ran product for a while, and he's doing bigwig things over in manufacturing with Royal Enfield in the beautiful central England. Well, that's it, folks. We have journeyed through Triumph's modern expression, and also taken a few side trips into lithium, etc., because, you know, it's all related in the end. And as Kevin likes to say, you get to a certain age and everything reminds you of something else. Thanks for listening, folks. Podcast is brought to you by Octane. We have the Octane Prequal Flex link down in the description. Go check it out. Click on the link, shop for a bike. See if you qualify. And if you do, you can go to a dealer like Cash and perhaps buy the motorcycle of your dreams. Appreciate you being here. We'll see you in the comments.